Hi everyone, welcome back to the channel. My name is Anuj, and in today's video we are going to talk about how do we implement OOPS functionality into your machine learning projects. So in this one we are going to take a very small data set, which is going to be a sales data set, and we are going to create classes and objects which are going to be based on object oriented programming. And in this project we are going to show you how can you implement classes and objects and methods into your machine learning projects, which is going to be really very helpful. In today's day and age, if you appear for any kind of machine learning interviews, you would realize that every interviewer or every organization heavily uses the classes and objects and OOPS functionality and up to some capacity, right? So you need to understand how can you implement the OOPS functionality into your machine learning project. So this is what we are going to achieve in today's video. So without any further delay, let's get started. And before we start, I just want to say that I'm giving the link to this data set in the description. Before we start, please download the dataset and be prepared. Do this side by side with me for a better experience. That's what I recommend. Now let's get into it. Alright, so now as you can see in my screen, I'm going to show you this micro project, which is going to have these 10 questions. Once again, if you want to learn in a much better way, download the dataset and do this side by side. You will get a much better idea. And I'm presuming that you already have some idea of what exactly are classes, what are objects, what is the object-oriented programming. I'll try to give you a brief in the middle, but nothing in detail. So that's something to keep a tab on. Now let's get started. So first of all, what we are going to do, we are going to import the necessary libraries. Import np as np1 visualization. So we can say I want to use matplotlib.pyplot, and that's it. So now I'm going to create a class for mm, performing data pre-processing. So let's suppose I'm saying using the class keyword, and I say create a class as data cleaning, create a class data cleaning. Okay. So now I'm creating a class, and in this class, what we are going to do is we have to define certain methods that can execute these questions or these tasks. So as you can see, we have to load a data frame as an object. We have to then drop some missing values to drop the duplicates, find out the total sales per product, total sales per month, total sales per year, best selling product, average daily sales, and so on. Okay, so for this one, the first thing that we always want to do is, so when we create an object, the first thing which is going to happen is this function will automatically be called whenever we are creating an object. So this init is called initialization, or you can say constructor. So now what I want to do is I want to say self.df equals to pd.read underscore csv, and I want to provide the path to my dataset. So I'll just fetch the dataset. Okay. So now you might be thinking, okay, so this class particularly is not taking any argument. So now what we are going to do, as soon as this function is being called, what I want to do is, uh, in fact, let me show you first so that you get some better idea. So I'm just showing you the data so that you get some better idea about it. And then we'll try to use the oops functionality to get this done. This is how the data looks: 1, 2, 3, and 4. These are the 4 columns. So if you look at this, date is taken as an object, product is a category, quantity is number, sales is a number, and these are the only 4 columns we have. So this is a very small data set that we have, only 4 or 5 rows, and that is it, nothing fancy. But we are only trying to implement and understand the oops concept and how do we use it in the machine learning models. So the functionality will be more or less the same. Okay. So the first task that we want to do once an object is being created and the data self is loaded. In this part, what's happening is we are loading the data set. So you can say load the data set. So the data set will get loaded into this object as soon as we create an object. Okay. Now the first thing that I want to do is I want to convert the date to date time. Okay, now what I'm doing is my date is actually a category, as you can see. I don't want my date to be a category. Let me show you once again from the beginning. So what we are doing is we have loaded the data set. We have checked the first few rows of the data. There are only 4 columns. Upon checking the data types, you can see that the date is actually in the categorical format, uh, or you can say string format basically. And then we have product, which is string, Then we have quantity and sales, which are numerical. So what we are going here is, so the data set is getting loaded. Now the first thing that I want to do is I want to convert the date from string into date time format. I'm not sure why am I getting these suggestions in the first place, but yes, to access the data frame object, it is going to be self dot date. So you access the date column, we can use the pd to underscore date time, and then we can say self dot tf date. So what we are doing is we're taking the date column, which is a string value. Then we are using the date time module, which is available in pandas. And then we are basically creating and we are restoring it in the data frame. What's happening now is that data is getting converted into proper date time format. So first of all, let me explain what problem have we solved by doing this conversion. Now, because your date is now converted into proper date format, what you can do is you can extract the month, you can extract the year, and then you can do analysis on months and year, which is primarily the task. When you are doing data analysis, it might have a timestamp, which is primarily going to be a string. So this is automatically what you have to do. Okay, so I do not want to call this method, and that's why as soon as you call this method, it's going to happen automatically. But all I have to do is I have to also provide a format. So what is the format of my date? If you go ahead, you can see that this is year first. So we have year, then we have month, then we have date. So somewhat like this, and then for errors, of course. So this is the conversion that we have done for date from string to date and time. Now what we are going to do is we are going to create month and year column. So now we are going to create this new columns. For this, we are going to create a function. Yeah, we can call it as create month, uh, month and year. So for this, what we have to do is now to access the data frame, you have to do self.tf. You can define, let's suppose I want to create a month column. Okay, so what is going to happen? Self.tf, and then I want to say date, and then we can say dt, which is for date time, and then you can say month, and then similarly create one more column as year. Self.tf, take the date time, and then use the year method. I think it is the year method. So now we have created the year and month column now, and sometimes what can happen is we might get some errors as well. So what I'm going to do is we are going to put this into try and catch blocks. So let's suppose I would say try to complete this. Okay, so we'll try and get this one. And then what I'm going to say, I want to say that month and year columns have been created successfully. Yeah, let's say that. And then I want to say, let's suppose self.tf head. I want to just print this. This is just to check that these columns have been added. Okay, so we have done this one. And now what we want to do, we want to define an exception. Let's suppose I've taken as E, just simply exception has occurred. Now what we want to do is we want to return something. Function should return something. If the function is not returning anything, you will not get any output. It will just implement the changes, but you will not see any output. Okay, so this is what we have done. Now we will start. Now we are going to show the drop missing values. So let's suppose we say missing values. Okay, so we have to pass a parameter. Self is always going to be a parameter. Okay, now self.df will access the you can say data frame, and to drop the null values, what we are going to say drop na, and then we can say in place equals to true and access equals to 1, access equals to 1. Okay, this should do the job. Okay, and then we want to return something as well. So we want to return the columns as well. Missing values are done. Now we want to remove or drop duplicates. So similarly, I'm going to create a drop duplicate or drop duplicates. So we can set create drop underscore duplicates, provide self as a parameter, and then I can say self.df to access data frame dot drop underscore duplicates. I'm not sure why am I getting these suggestions here. I want to suspend them. It just ruins your overall experience, man. Everything is disabled, but still I'm not sure why it is working. It seems like it's already disabled. Okay, let it be. It's a good thing anyways. So we are dropping the duplicates. Okay, and dropping the duplicates. Let's suppose we want to return these columns as well. Now the next thing that we want to do, total sales per product. Now this is important. We want to get the total sales per value or per product. So we want to group by the product, and basis that we want to get an aggregation of the sales. That's how we are going to achieve this. So now we are going to say get product wise sales. Okay, so we can say create product wise sales and take the self parameter self dot df now dot group by. Okay, so we can provide the column. So the column is going to be your product. Now once it has been done, what we want to do is we want to get the sum, or the sales column. We want to take the sales column and get the sum of it, and this is how we are going to achieve this. We don't have to return every single time. Okay, so this is how we get the product wise sales. And next question is total sales per month. Total sales per month. So now we have got the month column and year column per month, so we have to group by month and get the sum of sales, I guess. Okay, so let's suppose I try to find monthly sales. It seems like it can literally understand what I'm trying to do. So to get this cell.df to access the vacancy data frame, then provide month column and then sales column, get the sum, and bingo. Similarly, we could do this. Okay, you don't have to return anything though. You can say monthly sales, then we can say yearly sales. Now that we have created this part, we want to get best selling product. To get the best selling product, what we want is define best. I'll just say best selling underscore product. Provide the self parameter colon, and now just scroll down. So what I want is I want to group by product. So you want to group by product and then you want to take the sales, get the sum. Now once you've got the sum of the sales, so what you want to do is you want to sort the values in descending order. And once you've done that, you want to get the top value. So only the top value uh, should do the job. So I can maybe pass on the index, but let's see what it returns any which ways. Okay, and now let's see what else do we want to get. Now we want to get the average daily sales. So for this one, average daily sales, we want to group by date. For every single date I want to get the sum of sales. So similarly, it's almost same. Okay, so for example I can say average underscore daily underscore sales, provide self parameter self.tf dot group by, then I want to get date column, group by date, then I want to get sales, then I want to get the sum. Okay, so this should give me the average daily sales, and these all functions have been created just now. Okay, so we can say best selling product, then we can say average daily sales. Now what else do we want? We can say plot sales. Now we want to get the plot of the sales trend using the line chart. To get the sales, what exactly we want? Almost the same thing. So now we can just do the almost. For example, we can say sales trend df dot, sorry, so dot df, and then I can say no sales trend. So to get the sales trend, what we are going to do, we want to draw, let's suppose, product wise sales, and we want to, let's suppose, say plot. We can say kind equals to, let's suppose, line. I want to create a line graph with this. Okay, now what I want to do is, because I've already taken PLT, so we can define the PLT X label as product, PLT Y label as sales, PLT dot title sales trend. Then what I can do is I can just do PLT dot show, and this should be done. So this is my sales trend. Next, what you want to do, you want to get product wise product wise quantity. So again, product wise quantity is going to be almost same, wise quantity. So it's very simple. Again, we just take product wise quantity, take the data frame, group by product, then get the quantity sum, and that should be it. Okay, that should be it. But let's suppose I want to draw this. Let's suppose I want to plot. No. Let's suppose I want to create a bar chart out of it, and this time I can say create your X label, product plt dot y label, quantity plt dot title, product wise quantity plt dot show. Okay, and this should give me the product wise quantity. So I'm getting all these methods, and if I run this, all these methods have been created. So you can see I've created so many. So when you basically create an object, I'll show you how this happens. Okay, so I'm going to show you how to access all these methods. So you can do all these steps individually as well, but when you create a class or when you do work with a with an object, so I'll show you how what happens.